everybody, this is Todd Frazee, and this is the tutorial for assembling the TCOSE drive assembly. Now the drive assembly in the drawing isn't labeled such, but there is a drawing of the flywheel and associated components going together. So we're going to call that the drive assembly. So the first thing we want to do is we want to save our file as the TCOSE drive, and we're going to abbreviate assembly, ASSY. Alright, so then, so according to your assignment, you need to assemble the dash 4, which is the flywheel, with the drive shaft, which is the dash 6, and 2 instances of the dash 7. And we're going to download the associated pins. So we have the small pins that peg the drive shaft to these crank arms, and then we have a pin that goes into each crank arm that connects to a rod, piston rod, connects to the dash 11 assembly. Alright, so let's go back to Fusion, and we're going to go to our data panel. And the first thing we have to do is we have to save our file. And so we're going to call this the TCOSE drive assembly. And we're going to abbreviate assembly as ASSY. And then we're going to drag in the dash 4 component. It's the largest one. Everything mounts to it. So it makes sense to have it as our first feature. We can accept its current location, and we need to right click on it and ground. The next thing we want to do is we want to make sure that we're working in metric, because the rest of the assembly is in metric. Okay. Bring in the drive shaft, which is the dash 6 part. Okay, once that loads, it's throwing it in the middle, and we don't want it there. We'll drag it off to the left, and let's rotate its orientation so that it's similar to how it's going to go into the part. So we're going to rotate 90 degrees, select OK. Now we're going to use a rigid joint. These two components don't move in relationship to each other once they're assembled. They're either bonded with Loctite or press fit. So and it's designed to be centered on the flywheel. So we're going to try to use the rigid joint on the cylinder and the hole, but pick up on the midpoints of them with the snap points. So let's select joint. We're going to select our major cylinder, and as you see, the midpoint is selected, the blue triangle. And then we probably need to rotate the cylinder around. So highlight the cylinder, and we're going to try to grab the triangle in the center. It's a little tricky, and there I have it. So our snap point is going to align the rigid joint in the middle of each of those two components. Select, and you got a rigid joint. Make sure this icon is showing. Let's say a little mountain range. Hit OK. We've now assembled the first two components together, the drive shaft and the flywheel. Now we're going to bring in the TCOSE 7 component. Which is the, they call it a crank plate and pin. I would call it a crank arm, but let's slide it up so it's out of the way. And our pin location that pins the two parts together is vertical on this one. So the first component, we're going to rotate it 90 degrees so that the corresponding pin is aligned, and the diameter that goes onto the shaft are aligned. Let's select OK. Now we're going to right click on that 7 component because we need 2 instances of it. We're going to right click, you're going to say copy, you right click into the white space, and then select paste. Now we have 2 copies right on top of each other. So let's drag our copy over to the right. And this one goes 90 degrees opposed to the first one. So let's go ahead and rotate this one 90 degrees, and that way its small pinhole will align with the corresponding pinhole in the shaft. Alright, now we're ready to create rigid joints. Let's do a joint between the first arm's outer surface, so snap point should be in the same plane as the outer surface, and the one end of the drive shaft on center. We now have those rigid joints aligned. Now we're going to repeat the procedure on the second one. Select joint, center face, outer face, so we need to rotate, center outer face of the arm, zoom out, and we'll zoom in, and we're going to select the center face of the drive shaft. There we go. Hit OK. So now we have all the custom components aligned and assembled for the drive assembly. Now we need to bring in the 2 pin components, and there are 2 instances of each. We need a 4mm hole pin, and we need a 1.5mm pin. We're going to go out to our resource, Master Car, within Fusion 360. Select Insert from Master Car, and we're going to type in Dowel Pin. Okay, we come up with a variety of pin types. We're going to select pins. We're going to select dowels. We're going to select metric. We're going to select 4mm, which is the diameter of the larger diameter pin. Okay, we're going to pick plain shaft, stainless steel, 3/16 stainless, chamfered end, the plain head and plain end type, and the rest of the settings we don't really need. We do want to set a length, and according to our drawing it's 9.5mm. Now that's not an option on our list. We can try typing it in, but it looks like we don't have a standard 9.5mm pin. So let's go with 10. It'll just mean our pin will stick out a little farther. If it really bothers us, you can grind it down to 9.5. We're going to go to product details. Scroll down, you see the drawing, and it won't default to SAT, but you want 3D SAT, and hit save, and we receive our model. Drag it out, and what's nice is the model has the part number in it and the material, so you have a reference for that. And let's rotate this copy 90 degrees so that it's in alignment with the pinholes. Select OK, and on the feature tree, component tree, right click, and we're going to copy this component because we need a second instance of it. Right click in the white space and hit paste, capture position, and we'll move our second pin over to the location where it's going to go. Hit OK, and now let's create our rigid joints. Going to select joint. We're going to look at the back side of this pin, and we're going to pick up on the center of the face with a rigid joint, and then we're going to look through our model. We're going to pick up the center of the hole on the back face of the arm, and that'll align those faces. Select OK, and we're going to repeat this procedure on the opposite side of the assembly. Joint, center of the pin, and then the center of the back of the hole. And OK. Alright, so now we have 2 more pins to put in. They're the 1.5mm diameters. that secure the pin from rotating on the shaft, or I mean the arm from rotating on the shaft. So we're going to go back out to our vendor here. We're going to go to Insert from the Master Car. We're going to type in Dowel Pin. Select dowel type, plain, plain end. We want a chamfered end. We want metric. Our diameter is going to be 1.5. And then our substrate, the length. It does call for a 10 millimeter length on our drawing. Stainless steel, 3/16 stainless. And that's about it. So we've got our one dowel pin that we can pick from. Hit product detail, scroll down, 3D SAT, hit save, pops it into our model. So it's already in the orientation of the pin on the opposite side. So let's go ahead and move it over there. We'll select OK. We're going to right click on the component in the tree. We're going to say copy. We're going to right click into the empty space, select paste, capture position, and then we're going to bring our copy or duplicate over. And we want to rotate this one in the orientation of the hole it's going in. So we grab onto the circle and we're going to spin it till it says 90 degrees and hit OK. Alright, let's finish this guy off. We're going to hit joint. We're leaving it on rigid. Pick on the center face of the pin. I'm going to rotate to the bottom. Look down into the very bottom hole. You're seeing the hole going through two parts. So you want to get the very bottom and center of it. It'll plug the pin into that hole. Now let's get our second pin. We need to look at it from the end. We're going to select joint. Select the center of the pin face. And now we need to zoom and look at the hole it's going in. So over here. We want it at an angle so you can see the bottom, and our snap point should be the center of the bottom. There we go. As Titan would say, BAM! Alright. You've just finished this, and this we can go back to our home position. And you have now the drive assembly. We'll be able to bring this sub-assembly into the major assembly, and it'll make it much simpler to assemble. Make sure you save, and now let's move on to the next one.